welcome to the Journey Chez Chem. Please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. We are balancing number 1 in basic solution by the half reaction method. And therefore, the very first thing we must always do is find the oxidation numbers of the various elements. Well, any element that's standing alone by itself must be 0. Just like compounds, it's 0. And in water, oxygen here is -2 and hydrogen is +1. It has their normal charges. Well, here we have a polyatomic ion, or actually a ligand, but we haven't talked about that, and that will come much later on in your chemistry education. But hydroxide has a -1 charge, and there are 6 of them, giving me a -6. Well, the whole polyatomic ion has a -3 charge, and therefore aluminum is following its always, always, always silly 6 as +3. And hydrogen here is a diatomic molecule, and it's standing by itself, and therefore it is 0. So what has happened here is that aluminum has changed from 0 to +3. And therefore it has lost 3 electrons and is oxidized. Hydrogen has gone from +1 to 0. And therefore, it has gained 1 electron and has been reduced. And then I separate into my half reactions where the brackets are. And I have aluminum, which goes to the aluminum hydroxide. Now, in this case, remember, when we are in basic solution, we can only add water, electrons, hydrogen ions, and hydroxide ions. That is all that we may add to these reactions. Well, when I have a hydroxide, I can directly add hydroxide. And I need to first add my electrons, and I lost 3 electrons, and you'll recall that losers are produced. And therefore, I add the electrons to this side to balance that charge. And then I'm going to add my 6 hydroxides. And that's all I have to do in the first part. Now, my second reaction, water, is changing to hydrogen. Now, it's very important to notice that when we do these brackets, it's always for a single atom. And we have 2 atoms of hydrogen. Therefore, we have gained not just 1, but 2 electrons. Now, I need an oxygen, and therefore I'm going to add a water. And when I add water, I have to add 2 hydrogen ions. Now, because it's in basic solution, I'm also going to add 2 hydroxides to both sides of the equation. Now, this becomes 2 waters. And it's going to cancel with this water here and only leave me 1 water. Now, before I can add them back together, I have to have the same number of electrons gained as there are lost. We have transferred electrons. Therefore, the top one I must multiply by 2 and the bottom one by 3, because the lowest common multiple is 6. Now, I'm going to rewrite them again with the multiplication. Well, I have 12 hydroxide ions and 2 aluminums and 2 of these aluminum ions and 6 electrons. In the second case, I'm multiplying by 3. And I have 3 waters and 3 waters. And I get 3 hydrogens and 6 hydroxides. Now, before I add them together, I'm going to do some canceling. Well, these 6 hydroxides totally cancel and leave me 6 here. Then the electrons must totally cancel, and I did not add those electrons. I have to have 6 electrons here. The 2 times the 3 gives me the 6 electrons, and therefore my electrons do completely cancel, which they must always completely cancel. Then I can add it back together. And I have 6 hydroxides, and I have 6 waters, and 2 aluminums, and 3 hydrogens, and 2 of the aluminum hydroxides. And because I have this 3 and 2, that is the lowest ratio that these coefficients can be in. And that would be my final answer in number 1. And we'll be right back to talk about number 2. In number 2, I'm using the format that we've seen in many of the worksheets. And OA is my oxidizing agent. Well, it contains the element that is reduced. Well, the element that is reduced is hydrogen. And H2 would be fine as well. And the compound water is my oxidizing agent because it contains the element reduced. Now, aluminum is oxidized. And aluminum is also the reducing agent because that is the whole compound there is actually an element. The total number are transferred in the half reaction that is oxidized would be this half reaction, and you can see that you don't have to have a balanced equation. This is enough information for me to answer all of these questions. And therefore, we have 3 electrons that are lost. In the reduction half of the reaction, we gain not just 1, but 2 because we had 2 atoms. And therefore, this would be 2 electrons. The total number that are transferred would be the lowest common multiple here, and that would be 6 electrons. Now, I need to talk to you a little bit about the format of the assessment that's coming up for you tomorrow. Well, you have a section where you are given an equation and you will be asked questions about that reaction, like these questions here. Or which element is oxidized, which element is reduced. So very much similar to this, only they will be in question form. And then you will have 3 reactions to balance. 2 will be in acidic solution, and 1 will be in basic solution. And then a few numbers to do oxidation numbers. And also there will be 2 equations where you will identify this portion here, the oxidizing agent, the element reduced, the reducing agent, and the element oxidized. But you will not have to do these elements transferred in those equations. However, you will have to do it at the beginning when you give me information about a general equation. And that's the format of the assessment. I know you'll do well. We've had lots of practice. And I know you do well. I just know it, like you do on everything. Well, thanks for being here, and I can't wait to see you tomorrow. Bye.